There we go, we finally made it. Fire up the soldering iron. Let's get a multimeter. It's tiny. Intermittent. I want to say that's soldered. Let's plug it in and see what happens. And let's see here. We should have a stand-up cord over here. Leave it to me, try to plug it in upside down. Alright, now let's test the output of this.
Do you remember how you held me then? Now you got me reaching out.
4.2 volts, so that should be good. 4.2 volts. Alright, let's unplug it. This is interesting. So is that an intermittent contact? Or is that simply static? Let's see. If I touch a pin in here. Okay, it looks like it's just physical contact, so it shouldn't be an intermittent problem. Alright, so let's get this thing off of here. Now we gotta desolder this little bugger. I could just solder onto the back. Let's see, I need to go from there. I better put a plug on it. See what the pin layout is. Okay, that should work. So, let's go to work on this and clean this up a bit. Alright, there's that side. Now we can cut it, and then we'll have to clean up the other side.
How long do I gotta keep you?
Hey all.
Hey, how's it going?
How's it going?
Going pretty good
you can
here.
Request a song by typing SR then the name of the song.
Hey there, Slayer. Have you been having a good day? Alright, let's smooth this side up.
Not bad.
Awesome.
I always hate Mondays.
Really? Well, you're probably working, ain't you? Or have to work, did work, something of that nature. Got off of work, maybe. This Monday was a little bit interesting. Had a bunch of updates done on my computer, and it took me forever to get the stream up and running.
Plus I always feel tired after the weekend.
Absolutely. Let me adjust that audio a little bit.
Regardless of how much or how little I did.
I understand that. There we go. Well, I'm glad that you can join us today.
Have submitted a request to my bank to configure online banking for my account.
Oh yeah. Is that bad? Are you having issues with that, or you just getting it going?
So once the request is cleared, I'm looking forward to buying some components for my Arduino Uno.
Oh, that's gonna be awesome. So did you end up getting an Arduino Uno, or what did you end up going for? I kind of want this laying sideways, but I don't know how strong that's going to be laying this way. But I do want it that way. I feel like that's I don't know, it feels right going that direction.
I've had an Uno for about a year.
Oh, okay. Just gonna break it out, huh? Get it warmed up?
Just haven't had the time to do anything with it.
I understand that. What's your plans? What do you want to do for your first project? I mean, we can bounce some ideas here. I'm looking for my case with all of my, here it is, connectors in it. I have a socket ready to go, but maybe I have a connector that'll work better.
As, on occasion, I forget to check whether I have all my essentials with me before I leave home in the morning.
Ah, I see. I think that'll work better. Okay, so I'd need that, and then I need a male end. So that'll go there.
I am going to have a motion sensor that notifies me on my phone.
Okay, so like if somebody comes by the house or opens the door or something up while you're not there? Is that the general idea?
No, before I leave my home in the mornings.
Oh, okay.
Will prompt me to check whether I've taken everything I need.
Oh, that'd be neat. Kind of a reminder bot. I like it.
I am sure I can use NFC for this.
Yeah, that should be fine. Alright, so is that in scene? Let's move it over just a little bit and up a little bit. There. That's in scene. Alright, now I gotta get this soldered on halfway straight. So let's see, I need to turn this one this way. Need to bring both of them up.
I am going to be purchasing all my components from
I'm not familiar with that. I'll have to look that up. Let me get this soldered first before something moves. Have you ordered from them before? Or are they just recommended to you?
It's an official Pi reseller.
Oh, okay. Okay, that kind of did what I wanted.
But it sells Arduino components too.
Well, that's cool. Alright.
Haven't ordered from them before, but they seem okay.
Cool. There, that don't look bad. Now let's see how much stress we can put it under so we know whether or not this is going to hold. Because it's not really meant to go that way. It's a little bit crooked, but I think it'll work.
Plus I feel safer ordering from a vendor within my own country.
Oh yeah, that's always better. Got a crooked pin. Very common when soldering, because you melt the socket a little bit. Get right up in there. There, that don't look bad. Come on, camera, auto adjust here. There we go.
Okay, so I submitted the request to my bank last Thursday, so hopefully I will receive something in the post tomorrow.
Awesome.
They say it should come within 5 days of the request being placed.
That sounds reasonable.
You
Okay, so that's not wanting to stick.
When there's no hope loving for you who saw me before I knew who I'd be. What I have around me.
Hi there.
Hey, how's it going? Been calling you all day, Red Hat. You don't answer your phone no more, huh? Put a drop right there.
I'm here.
Awesome. Well, at least you're okay.
Sorry.
Boy, that's so tiny. About need a micro iron to get that. No. Right there.
Turned it off for a few.
That's okay, as long as you're alright. I was just checking in on you. Alright, got that side. And got that side. Now, I don't know what you can see on the stream, but the bridge I just soldered is about, I'm gonna say, a quarter the size of a human hair, something like that. So I don't really know whether it held or not, but we're gonna hope it does. Alright, so now we need to work on this other side. Okay, so on the battery, let me think for a second. We're going to go directly from here, directly to the battery. And then from the battery to...
The lamps are looking large.
Yes, they are. I got it zoomed in pretty good. I'm going to go from the plug to the battery and the battery to the boost converter. Now comes the fun part. Getting these teeny tiny pins to wrap around teeny tiny wires. Alright, so we got those. And we'll run... Let's get... What color should we use? We'll use orange. Hey, Red Hat, pick a color. Blue, green, orange, or yellow.
Blue.
Alright, so blue's going to be our hot wire. I need to 3D print me up a new little case for these little guys, but I haven't gotten around to it yet. I think when I print a case, I'm going to put it, and let me zoom out a bit. I'll put it horizontally like that, so the weight of the rolls will keep them from backlashing rather than this way. So it'll sit like this on the desk. I think that's a better way of doing it. Okay, let's get back on our little guy. Well, we might go here. All right, so we're going to use wires black and blue.
Small plastic containers.
Oh, okay, awesome.
Oh.
All right, so now we got blue because Red Hat decided upon it, and we'll use black for ground so we don't get nothing confused.
You're welcome to them.
Okay, I'll get them. Alright, I'm stripping the wires for the battery. Trying to strip it without ripping it out of the battery. They got looks like plastic coating, so I believe it's PVC coating. Alright, Red Hat said blue for hot and black for ground, so do our hot wire here. And I already did that wrong. This goes to the hot. Blue for hot, black for ground. There we go. And let's get our tweezers out. Need to get me some, I got some somewhere, but I need to get me some new forceps. So I don't have to hold these as much. I get that in there. Right there. And that closed. There we go. Now we could do this other
tiny
one.
Work.
Yep, this is itty bitty right here. Oh, you know what I forgot to do? Forgot to put heat shrink tubing on. Alright, now I'm going to give it a dab of solder. Even though this is a non-soldering connection, I never trust them. So it's solder time. See how loose that looks? I just don't like that. There we go. Alright. That looks alright. Let me see if I have... All I have is the large ones. This is so small. All I have is the large heat shrink tubing. But on a good note, at least they'll fit over it. Okay, so that one's good. Let's go to the next one.
LOL.
You see how big that is? Like a big old straw compared to the work I'm working on, but it'll work. That's why it's just shrink tubing. It's not expand tubing. I need to not cross these wires because the battery may have a charge on it. And although it probably won't ruin nothing, I don't want to take a chance because there is circuitry in the battery, so I don't want to take a chance at ruining the circuitry. So let's just try to be careful and not short these two wires out. Alright, drop of solder. There we go. Get our mini connector. There we go. And it fell off. Get back up here. Tight enough, I have a hard time putting it on, but it's loose enough that it can fall off on its own. It's right in the middle. Alright, you hold still. Hold still. Gotcha. Now let's put a drop of solder on you.
Unine watch repair tools.
Just about. All right. Now I know it's soldered. Now let's see. I got both of those connected. Let's see if they fit in their plug. Oh, gotta make sure I put them in the right way. Alright, so we have negative. Let's put this in here. Pins are still a little bit too bent. Gotta straighten them out a little bit more. Alright, so on this little guy we got positive on this side and negative on that side, so Our negative wire should go right here. Nope, 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 nope. Undo that. Did it again. Forgot to put the heat shrink on. One, two.
Move the camera.
Oh, sorry. Thank you. Actually, I could probably back up now. And now it's all blurry. Let me adjust the back over to automatic. There we go. Okay. So I cut 2 pieces of heat shrink tubing. I'm going to slide one over each one. Here. And here. What I'm using them for basically is a little bit of insulation. And let me think about this for a second. I actually need a third one. Insulation and strain relief. So when I'm tugging on the wires and stuff, it won't, hopefully won't mess nothing up. Okay, so I need one to go around both of these. So there's that side. Here's this side. So both of them are through that wire, that heat shrink tubing. Then each one gets his own individual one. So one here and one here. Then we go back over to here, and this side's the negative, so we're hooking the negative up. Let's see, we need the little prong sticking this way, I believe. Okay, I believe that's in all the way. And then we have positive. And that pin's a little bit chunky, yeah. Come on. Okay, gonna have to work on that pin, I think. Alright, so this pin's a little bit bent still. Let's straighten him up.
I love those laundry pellets.
Oh, awesome. Make your clothes smell good. There we go. And it's in there.
YAEH.
Awesome. You know, funny thing is they do all that, but really you think that all that would be oh, let me turn my hot air on. All that would be taken out in the rinse, but it really isn't. Alright, so hot air on, and let's drop the temperature way down. We're not burning nothing up here. We're going to drop the hot air down to about 300. It needs to be lower than that, but I think 300 should be fine. And we'll put the actual air on 3. I can't see the screen, so I'm hoping you guys can see it. Let me see here. Okay, now I can see it. Yeah, you guys should be able to see this. So, let's do that right there. Alright, there's that one. Even at 300, that's pretty warm. Let me turn it down some more. Going down to 200. Bump the camera.
You stole my heart of gold after my silver soul. Can you dig any deeper now? I gave you all I own, put you on this golden throne, but
Go all the way around it.
I'm stronger now.
Alright. The last one over it. Normally I don't do that much heat shrinking, but because I don't have the proper size heat shrink, I figure I might as well layer it up so it'll tighten itself up as the time goes on. There we go. And we can turn our hot air off. Let's check our voltage, see if the battery is completely dead or not. Can't really get in there now. Let's see. Positive. Yep, I did get in there. What did it show? 3 volts? I think it showed 3 volts. Let's try it again. .5 volts, so that should be good. If it was shorted, then we'd have 0 voltage. So, alright, so that's there. This is here. Let's see if this plugs in, or we're going to have to mess with them pins some more. It's really tight, but it did plug in. Alright, now let's get our power supply. And we got a yellow light. Can you guys see that? It's all fuzzy again. Come on, autofocus. I finally give you permission, autofocus, and then you fail me. That's the way it works. Alright, let's focus this up here. Whoop, there it is. The yellow light. That should mean it's charging. So, that should be good. Let's go back to autofocus. And we can zoom back out. So, let's unplug this. Anything getting hot? Ooh, that little chip is getting warm. That's for sure. It must be putting out some power. Alright. So, let's unplug that. that little chip right there, he got pretty hot, so he must be putting out some pretty good volts. Okay, so we got this done. Now we're gonna connect on this one the voltage in. I'm thinking if I should use another plug or not. I feel like I should use another plug because I have more circuitry going in later. Let me think on this for a minute. If I run these two wires directly to here, I run a plug from here to there and plug it in. The other side. Okay, I should be alright. I should be able to tag onto the other side if I need to. So let's go about the same amount of wire. Let's go right here. Add about half that. Now we'll clip our wires off. Strip these down. Okay, now that's the question. Do I need a switch between here and there? If I leave that hooked up, it's going to be running 12 volts all the time, but basically no amperage, but it's still going to be drawing power. So I do need a switch. So we can use this switch here off of this guy. Because it's got a nice little on-off switch. Let me see if I use that between... I could switch this side here. But if I turn it on, then it'll have to be on in order to charge? No. If I turn it off, it'll still charge. If I turn it on, it'll just power up the unit. Okay, so that should be right. Alright, so let's get this little switch off of here. Or do I just want the wires? Decisions, decisions.
And watch me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush.
Yep, there's some crummy solder right here.
Take my eyes open to force reality. Why can't you just
Doesn't leave you much room for error.
No, it don't.
I live inside my own world.
Let's just not make a mistake. What do you think? That sound good to you, Red Hat? No mistakes allowed on this project.
Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me.
There we go.
I love everything
Now let's clean the switch
LOL,
itself
right.
up.
all around my room.
It'd be nice if that's all you had to do. I'm not gonna have any mistakes on this project, and no mistakes happened. That was it. That's all you had to do to fix it. Bet your Microsoft would want that. No mistakes on this project. Microsoft comes out perfect every time. Alright, so finding a way of holding this little guy. That looks pretty reasonable. And
It's coming.
I wanna taste your content, hold your breath and feel the tension. Devils hide behind
out with the solder wick.
It's a one-way gate to hell. I wanna taste consumption, eat faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out.
No mistakes.
No mistakes. Hey Red Hat, can you hear the music or do you hear any music?
Carefree lately, yeah. Just kicking up daisies. Got one too many quarters in my pockets. Count 'em like the four-leaf clovers in my locket. Untied laces, yeah. Just tripping on day. Dreams got dirty little lullabies.
Yes, I hear it.
Okay.
These will just ride around the nursery and count sheep.
Just right.
Good deal. Pretty bad when you use solder wick to clean up the plastic, huh? Alright, so let's get that one cut off. The solder wick away so we don't lose it. Alright, so we're going to run our ground wire. See there, they automatically tried to stick together. Okay, going to run our ground wire directly to here. So let's get us a nice blob of solder on our iron. Alright, blob added. We're ready to blob it up. Let's go right here and hit it with our blob. There's our blob. That's a cold solder joint. Gotta fix that. All that plastic's trying to, yep, all that plastic's trying to act as a contaminant.
You need smaller fingers, LOL.
I'll order some on Amazon. They got everything. Alright, so we got that one there, and then we're running the -2. Get our black wire here. And this ought to allow us enough length that we could place our switch where we need it at. Get us another blob of solder on our iron. There it is. Move this wire out of the way. Move out of the way, little wire. There we go. Move this wire into the way for blobbing. And commence the blob. Blob done. That's a blobbing good job. I do say so myself. Okay, now back over to here. Move in our part 2. Unhook our switch. voltage in, negative. We're going to go right here. So, let's get a little bit closer this time. And clear it up, because autofocus don't want to work right. Hello, autofocus, wake up. Nope, guess got to go to manual. Alrighty. Manual focus activated. It's called a mouse. Alright, here we go. Now we put this little wire right there. Let's get us another blob. Alright, hold her steady and still got stuff on my iron. All right, another blob. Those are just temporary for now. All right. Now let's bring this over here. All right, so let's put our voltmeter. We'll put it up to 4,000 volts. Not just teasing. And manual focus activated. Nothing there. Oh, we should turn the switch on. And we now have nothing still. 3.4 volts. Gotcha. So that seems to be working. Now we need a tiny screwdriver. Are you tiny enough, or do I have to get a tinier one? You're tiny enough. Okay. Alright, get right here and right here. Alright, you can't see the meter? Yeah, you can't see the meter. Okay. Okay, not hardly any change, so it probably means the battery's depleted. So if the battery is depleted, we'll need to plug him in. Let's turn this off. And let's plug in our charger. And watch our little light light up. It lit up. Now let's try this. Still at 3 volts, okay. Okay, so let's adjust this. Retest. Okay, let's see what happened here. We got negative in. Okay, so we got no voltage in. No voltage in. We have voltage down here. Let's turn this off real quick. And let's see if we got voltage between here and here. Okay, so we got voltage there. We turn it on. And we got no voltage. Okay, so the secondary circuit is pulling down the battery and the charger. So, did I go a little bit too far? Let's see. I went in 4 turns. That's 1 out, 2 out, 3 out. Still nothing. The half. 1. Half. 2. Half. 3. Now we're going back in. 1 full turn. Right there's 1 full turn back in. Testing the voltage.
BRB.
Nothing. Okay. So in is down.
Good evening at Mater Dash and at Reed Pot.
Out is up. Hey, Thor's Lost Kitten, how's it going? Still not good. And here to here is not good. Let's turn that off. Okay, so let's let it charge up for a minute. That little chip's good and hot.
What's a draft pump?
Okay, so when you have really bad asthma you have different inhalers you use, and one of them is has a little pump on it, and you have to use like a nebulizer. And so the updraft pump is the actual pump. That's this thing right over here. Let me turn it up here. There he is. That's this little guy right here that pumps the air. It cleans the air and pumps fresh air into the unit. And then that goes, whoops, now I moved it out of the camera view. And it goes for your inhaler. Well, the thing is you always have to have this plugged into 12 volts for either a car cigarette lighter outlet, or you have to have it plugged into a wall wart. And so I'm trying to make it battery packed powered. So you could charge it up overnight and then get 3 or 4 uses out of it and just like have it in your purse or something like that. This is actually for my wife. Shh, don't tell her. We don't want her to know. It's top secret and classified. Alright, so let's see if we're getting any. First of all, let's move this out of the way. Let's put a ground plug right here. See if I can do that or not. Come here, you. There. Now my ground's permanently connected. I can try and figure out what's going on with this thing. If I could get this guy to grab hold of here. Better get a... let's see, here we go. All right, so let's take this here, move you back out of the way.
Cool idea. Sounds like a quality of life improvement.
Yes, that's my hope. Kind of, you know, you can charge it up overnight like you do a cell phone. Charge it up and then carry it with you. Okay, let me adjust this. So, here's what the circuitry is. Because you might have just joined us here. Let me go back down here. Okay. So I have a USB charger. Whoops, still not in frame. Still not in frame. There it is. I have a USB charger. Charging up a battery pack. That's what's charging up right now. The battery pack is approximately 4 volts. It's 3.3 or 3.47. Then I'm going to run it through a boost converter. That'll boost it up to 12 volts. And then from the boost converter, run it to the pump. So that's the circuitry right now. Switch and then a boost converter and then a pump. But we're not getting anything out of the boost converter. So I'm trying to figure out if we just have too low a battery and we need to let it charge. Or if I've wired something up wrong, or we have a defunct boost converter. So it could just be an adjustment too. So we're kind of in the middle of everything. So that's where we're at right now. Let me zoom this out. You can kind of see what's going on. There we go. So it looks like if I screw the potentiometer out, the voltage goes up. So let's see here. We're getting 0 voltage right now.
Can that setup safely provide enough amps?
It should. The battery can provide 1 amp to the boost converter, and the boost converter should be able to provide 1 amp. Well, it's capable of providing 3 amps out, but within safety limit, I'm giving it 1 amp out, and this only requires 800 milliamps, the pump. So, and that's at when it first starts up, because I understand, you know, motors, they have to wind up. So when it first pulses, it requires 800 milliamps, and after that, it settles in about 400 milliamps. So it should work fine. Everything is within spec, but it's kind of Chinese spec, so I don't know how much I could trust their specs. That's what the test setup's for right now. We're trying to see what we got going on here.
Only 800?
Yeah, only 800
Okay.
milliamps.
Makes sense, I guess.
When you first kick it on, it pulls 800 milliamps, and then it goes down from there. I think it settles in. We tested at about 300 milliamps. We was testing on another stream. Okay, not getting anything right now.
Dollar is time to have a drink. We need to stay hydrated.
Oh, yep, it is time. Okay, I think I saw it spike up or move. Let's keep turning it. Got to get a different screwdriver, I think. Hold still. I love these little bitty potentiometers.
Who on earth curated this Twitch word ban list?
Oh, I just got a whole bunch of, hold on a second, let me turn that off. I got a whole bunch of non-copyright music running. Feel free to go ahead and do any song requests. It should be up and running. I think the song request bot's running. Nobody's requested nothing today, so either it's running or it's not receiving anything.
Plus, S are all about that bass.
Might not be running. Exclamation point.
I'm soldering myself over here, don't have YouTube up. S are all about that bass.
Okay, let me try it on the other chat real quick and see if it's working over there.
S are all about that bass. Mater dash dash the song Megan Trainor. All about
right,
that
that's
bass.
working.
Official music video has been added to the queue. SR sale. Mater dash dash the song AWOL Nation sale. Official music video has been added to the queue. Is that a Discord proxy? SR Viva La Vida.
What's
The
a
song
Discord
Coldplay,
proxy?
Viva La Vida has been added to the queue.
The bot? Oops, don't want to do that. Hold on a second. Move my bot over. There we go. Is the bot epoxy? Is that what you was asking? There, we got 3 songs lined up. Now somebody else can add them and kick them off.
Yeah.
No, I'm using Streamlabs chatbot right now, but it is connected to Discord, so if anybody requests songs in Discord, it should, in theory, move it over to chat. Also, if anybody chats in Discord, it should my bot should relay anything that's typed in Discord over to everybody else in Twitch. The same thing should happen if anybody does anything in YouTube. It should relay it to Twitch, and Twitch should be relayed to YouTube. Everything should be nested together. So all three platforms ought to be nested together right now. Should be. That's the way it's set up, but... Alright, let me see if I can just get a different screwdriver here. That's a bigger screwdriver. Let's see what we got.
Okay. I think the command was just broken because of the plus and question mark prefixes.
I think so, but the bot added it itself, so I'm wondering why the bot's adding plus and question mark. I have to go back through and look at the programming and see what it's thinking. It must have got confused or something, because it shouldn't be adding anything to anything I type into the bot, but for some reason it did, so I don't know.
Because you know I'm all about that bass, no trouble. I'm all about
So what are you soldering over there, Lost Kitten?
I'm all about that bass, no trouble. I'm all about that bass, bass. Yeah, it's pretty clear. I ain't no size 2, but I can shake it like I'm supposed to do. 'Cause I got that boom boom that all the boys chase, and all the right junk in all the right places. I see the magazines working out Photoshop. We know that shit ain't real. Come on now, make it stop. If you got beauty, just raise them up.
May have to run this to a power supply and see what I get. Alright, so let's try this again. There we go, that's 3.5 volts. Now why wasn't I getting that earlier? Was it just a screwdriver?
I'm just experimenting with the driver for my CNC spindle a bit tonight.
Oh, okay. Okay, so I got 3.5 volts, and no matter what I do to this potentiometer, nothing changes. I don't know about that. Let me flip this around so I can make sure I'm capturing a little bit of this. Alright, so back to the readout here. So we're getting 3.5 volts. I'm backing the potentiometer out. I'm already out like 4 turns, 5 turns, 6 turns, and nothing's changed. So something ain't right.
Linux, best OS to deal with printer drivers.
Oh, I bet. I used to run 100% Linux boxes.
3.5 the input voltage it gets?
Yes, well right now I believe it is. Around there, it's 3.4, 3.3.
Mater dash.
Yes.
At that underscore your underscore fan, uneasy face. Hey Thors.
How are you doing, that your fan? What's up with the uneasy face?
I said screw it and just use my phone to print anything.
Sounds like a winner to me. Alright, now we're going back in because I think we went all the way out and nothing changed. The thing is one way or the other, even if it isn't being supplied.
The same thing today, I printed via USB stick afterwards.
Even if this doesn't provide enough voltage to power the boost converter, it should be able, the boost converter drops it down to 1/2 volt. So one way or the other, this boost converter should be dropping the voltage. Well, don't say that. I'm inventing it. Shh. It's not messed up. It's just in process.
Of all the printer drivers Linux Mint said it could download, mine wasn't one of them.
Oh, way to go, Linux. I used to run all Linux boxes for a long time. When Windows 10 came out, I finally swapped over to Windows 10s. Prior to that, for like 5 years, I ran 100% Linux. Okay, something's definitely messed up with the boost converter. Don't know what, but something definitely is not quite right with that. Alright, so let's try this.
Doesn't Mint use cups? Normally you can download the PPD for your printer and satisfy it with that.
Normally you can. Unhook this. Alright, so we got a positive. Let's run positive 5 volts. Golly, seems like every time I turn around there's something else I need to work on. I need to spend a whole day just fix stuff up here in the lab. Alright, get this little banana plug flared out. There we go. Alright, so we got 5 volts. Ground. Gotta fix the ground banana plug now. Okay, ground. And 5 volts. Power on. It's showing I got it. Let's see what this was reading. And the verdict is 4.9. That's close enough. Okay, so we got 4.9 volts coming in right here. And this is 1 amp for sure. So let's run this on input to positive. And, oh, get you out of the way. Get out of the way. There we go. Negative. Okay, then let's connect negative right here and positive right here. Now we're getting 4.8 volts. Yeah, something doesn't seem right here. Let's do some more adjusting and see if it's this potentiometer. I have a feeling this potentiometer is messed up, or the whole boost converter circuit.
Well, that, and I don't have the special cable.
Special cable for your printer. Alright, we're going to back this out. May have to replace this potentiometer. Well, I hope it is. Hope it's just a potentiometer. You guys can't see the voltmeter. Let me move this around here. Now you can see the voltmeter. Nothing really to see. Nothing's changed so far.
Hate when I misplace the Wi-Fi cable.
Yeah, them things are hard to spot sometimes. Oh, it changed. Okay, so there's 2 volts. Did something come loose? Now we're down to 0 volts. Okay, I have a feeling it's this potentiometer giving us problems. Let's switch this up for a minute. Alright, so we got plan B here. Identical thing. Let me see where I can clip this at safely. Okay, voltage out should be safe. Voltage in is not safe. So let's go with the little baggie again. Then let's bring up our negative. Put the negative right here. Okay, so we got that there, and let's run our negative here, our positive there. Let's put this here before we tap it. Let's tap it on there. .8 volts. Okay, so that's 4.8 volts. Exactly what's going in is exactly what's coming out. Let's turn it up a little bit. The half a turn and a full turn, no change. Going back to where it was. And now we'll back it up. So that's out a half a turn and a full turn, and again nothing changes. So am I just missing something on this circuit? So let's see if we can follow this circuit. Let me turn the hot iron off. Brand new parts that don't do nothing. Very nice. We got voltage in, negative, that's running to this ground plate. Voltage in positive, that's going here to this inductor. Coming out of the inductor, going to this diode. Going out from that diode over to, and it looks like this capacitor. And I can't tell after it hits that capacitor, but I believe it's going to that chip. Okay, this voltage goes here to this capacitor. Huh. So let's see what we got going on here. Here to here, we should have a voltage drop of some kind. Okay, that sounds reasonable. Here to here, about halfway. About halfway. So the potentiometer is trimmed right center pretty much because there's 2.19 and 2.41. So we still have 4.8 output.
Woke up, told myself to push and never stop. I've been stressed out, watching both these hands around the clock. With my eyes wide, trying to get the panorama shot.
I
Nothing
could go to Walmart for a new one, but I don't wanna.
for a new Wi-Fi cord. Nothing across the diode.
Waiting all my life, and it was right before my eyes. Watching all this time slip by. Now I realize, you know I've been waiting, you know I've been waiting, you know I've been waiting.
There's our pot right there on this pin. Look at the other pins. That's a full 5 volt.
My whole life I'm forever grinding, waiting for my time to shine just like a diamond. When life is rough and I ain't with that funny stuff, I use it all as motivation, but it's hard to have the patience. Watching time
It seems like everything should be working.
to do in life, frustrated that I ain't where I want to.
And yet, no matter what we do, we can't bring it above the same voltage it was. Did you see him? There he is.
I've been waiting all my life, and it was right before my eyes. Watching all this time slip by. Now I realize.
Cute.
I've been waiting all my life, and it was right before my eyes. Watching all this time.
He was just exploring. He probably felt the heat from the iron and was like, wonder if this light's giving off some heat. Alright, let's go here. Back to our mystery potentiometer, which I think's the cause of our problems. Move out of the way. Okay, we're gonna go in 3 turns. Half. One. And a half. No change yet. Two. 2.5.
And we're flying so close to where.
3.
And we're trying to go somewhere new.
So that's 3 turns in and nothing changed.
Crack this iceberg open till it shatters through the ocean. I wanna make shockwaves. I wanna make shockwaves with you. Gonna move current till the winds flood what's been burning. I wanna make shockwaves. I wanna make shockwaves.
Let's see what we got here. This has got a cap on it. This one's got a cap on it.
Higher
That one don't. Yellow.
Were the pot solder connections okay?
Yeah, they look fine. Nothing, honestly, nothing looks wrong with any of it. It just makes me wonder, is the chip not functioning, or is the potentiometer not functioning? You know, it just something can't be right, because you shouldn't turn it 3 full turns and nothing have an effect. Turn this one off, turn that one off. Alright, and we need to go back to pull one of these ones loose. Put you right here.
Yeah, especially without load, you should at least see a response.
Exactly. I mean, I'm running 5 volts into it. It's got 1 amp at 5 volts, so there's no reason why, you know, we definitely got ample power supply going to it now, so something else has to be going on. What? I don't know, but something does. Alright, so let's check here. That's a clean 5 volts. What if we put a small load on it? Let's get a... Let's see if we can get absolutely more pins stuck under this one clip. How about that, guys? Let's see how many pins we can get stuck under one alligator clip on a third hand. That sound like a plan? All right, let's get you here. There. Alright, so now we should be loaded. And we're reading, let's see here, we are reading... Sorry I don't have the scope on screen,
I don't know
but...
what you mean. Looks perfect.
You guys are something else. Oh, let's see, VMAX, there we go. VMAX. PPV. I'm down to 100 nanoseconds, and it's putting out a clean. Let me make sure I got that right. 1 So yeah, pretty much a clean 5 volts for the most part. I mean, it's probably just the 4.7. We're going to go check this chip, see if this chip's doing anything on any of its legs, because it should be oscillating. No oscillation there. None there. Well, that's going to be the pits if all this time and we don't have a viable boost converter. Especially because they're brand new. I mean, you guys saw I took it out of the package and just connected basically 5 volts up to it. There's, you know, there's no way I could have shorted anything out. Haven't soldered anything on it. Looks like the processor is not putting out any kind of a pulse.
If you like what you see, or me as a streamer, don't forget to hit that follow and or subscribe button. Follow and join my Discord to stay up to date with the stream.
I will hit that follow button. We'll hit that subscribe button. As soon as my parents give me my allowance. Where are you at? Okay, there's something. Okay, so this is going to negative. Looks like negative 4.5 volts. So technically between here and the other side, that would be 8 volts. But why is it giving a negative voltage? Okay, let's think about this for a second. Turn the power off. Boost converter charges and discharges a coil or an inductor. The electrons in the inductor flow so fast that they don't want to stop moving, so they charge up a capacitor beyond the original voltage before it stops. At which case the chip activates and drops the voltage or drains the voltage out of the capacitor, and then the whole process starts over again. So we got our voltage going into the capacitor.
I've gotta head out. Good luck with the circuit.
Absolutely. What if this thing's labeled backwards? Have a good one. We'll catch you later, Lost Kitten. What if this circuit is literally backwards?
Chippy Acuario, thank you for the follow.
Thank you very much for the follow. I really appreciate that. So let's test the theory. Let's just connect this up the other way around. In reality, it shouldn't affect nothing if it's wrong. Because none of the components should be, I mean, you know, it should be reverse capable. Okay, so let's put this here, this here, slide you over. Right about there. Alright. Now, let's throw the positive lead over here and see what's going on. Okay, nothing.
I know better than to call back. I missed your call. I finally think I'm fine with that. I know it.
Well, there was something.
But it's your fault. I wish you'd just accept that. I got a better place to be, where the only focus is me. Me and weightless got me feeling like I'm flying. I've been holding on to these dreams. I'm ready to take the leap, 'cause I've been holding that in all shots.
Okay, so it's just not allowing it. The negative flow of this diode is stopping it. So literally it can't go that way. So do I just have two dud boost converters? I don't want to believe that.
Say, will I look blue? I won't sacrifice no more pieces of me. I got a better place to be.
But it is quite possible.
This is me. Me and weightless got me feeling like I'm flying. I've been holding on to these dreams. I'm ready to take the leap, 'cause I've been holding that.
Replacing it back the way it was. Yeah, let's do it that way. 4.3. Reversing it again. Okay, there's 1.3.
Find me
No change.
in the corner of the room, not ready to resume, 'cause like I'm taking. Don't wanna be alone, but I'm not in the zone. I'm looking for somebody.
4.83 still. Okay, that is 8 turns, 9 turns, 10, 11, 12. We should be out of range. 13, 14 of the potentiometer, 15. So we should be all the way out. Now we're going in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a full sweep in both directions. And there's no change in the output, so it's got to be this. So literally I got two messed up boost converters. New from factory. Well, let's check the rest of our circuit out. Yep, that's pretty bad. Let's go here and here. If I put my arm in the way, then you won't be able to see the voltmeter. So let's try it right there and flip the switch. We should have around 4 volts. 3.36. Okay, so our charging circuit's working. Our battery's not overheating. Our charging circuit's hot, very hot, but it ain't overheating, so I think that's going to be fine because that's a tiny chip. So it's going to get pretty warm while it's charging. So I guess this project goes back on the back burner for now until we get a boost converter. I could probably invest in a little bit better switch too. I have larger switches, but they nothing there. They are a little bit too big for this project. I think they'd be a little bit too bulky. But on a good note, let's see if I could show you this. Alright, putting the motor here.
The charge controller has no overcharge discharger.
Yes, it does. It doesn't, but the battery itself does. The battery has the circuitry built in. The charge controller does shut off at 3.4 volts, and it has an under voltage also. Alright, so I was using this one. Excuse me guys, sorry about the cough. And this one. On a good note, can you see everything? I think you can. Running directly from the battery. Well, technically the battery and the charger because they're both running right now. Go right here and right here. The pump does work. So all we need to do is increase the power to it. Because if you put pressure on it right now, it won't be able to run. But it is working, so in reality, our circuit is pretty close to running. We just need to up the voltage a little bit. Okay, so your question. Inside the battery, if you look, see this bump right here? I'm not going to cut the battery open, but KC, yeah, you can see that bump. There it is. Okay, inside here, there's a tiny circuit board with one onboard chip, maybe two, a few resistors, and a diode. And
a couple charge collectors would help also because buck boosters don't give the greatest flow.
That's true. So inside here, there's a charge protection circuit directly for the battery. If the battery goes below a certain voltage, it'll shut it down. And if it tries to overcharge the battery or overheat the battery, then it'll shut it down. So inside here, that's why I picked this battery. It's actually, I could do cheaper batteries, but this one was already self-contained because I wanted two redundancies. I got redundancy here, and then in the smaller charge circuit, this little guy right here, it charges at 1/2 amp. And
by Gotica, self-regulated.
Yes, it has 1/2 amp, and it has shut-off protection at 3.7 volts, I believe it is. That's why, if you look, you probably can't see it, but right here, there is a jumper, which I used a piece of copper wire going from here to there. And it's a little bit smaller than a human hair. It's probably about a quarter the size of a human hair. And that selects the amperage, and it also selects the over voltage. So I didn't think this was going to really work. But so far, this is the thing that is working. So that's interesting. So I got the battery charging. It appears to be charging fine because the light will go out once it's charged. So that's good. We got that going. We just don't have a boost converter, which is really annoying. I'll probably start taking these apart if they're not going to be working anyway. Find that very disappointing. But that's the way it goes sometimes. So how are you doing?
I have the same charger and converter on my desk here.
Oh, really? Awesome. What are you working on, old gamer? Or are you working on anything? I don't know, you might not be. Let me put this back in here. Tell you what I'm working on right now next is changing up our music playlist. What do you guys feel like? Country, rock? Give me a.
Well, I have used it a few times in different LED experiments.
Give me a genre and let me know what you guys are.
Rock.
Rock. Okay, we're looking at rock. We got 1 vote for rock. Copy link address. We got top 500 rock songs of all time. So let's do that. Because I'm a little bit tired of what's playing right now. It's pretty much sounded the same for a while now. So let's change that up. Give it a minute to populate. Takes a while for it to load 500 songs. All right. Randomize them. And start playing one.
I'm wondering if you're putting enough power into actually regulate it with that module. If I don't put more than 5V into this, it won't work, but it will take 5V and make it 11-ish.
Really? So you think a problem might be that it needs a full 5 volts? I can give it as much as I want. Let me flip this over. I can give it 12 volts. What in the world?
I think it needs the full 5V.
I'm gonna do a song about a dirty, dirty woman. Yeah!
All right, let's see what we can do here.
Gazing through the window at the world outside.
All right, so we got in
Will Mother Earth survive?
positive and out negative.
Hoping that
Let's find out.
losing her sometime. After all
Oh, let me see what all's in review here. Okay, so you can see the voltmeter.
we are still fighting
And
our lives. Watching all of history repeat
here is our tiny circuit. First, let's power it up and see if anything blows up. Nothing yet. Nothing's hot. That's our input voltage. And we got 12 going in, so we definitely got enough power now. Out.
I watch the sun go down like every one of us.
We got 11 volts out, and basically 12, same thing. Now let's spin the potentiometer around.
A better place for those who will come after us this time.
No change, and we're 5 turns in. 6, 7, 8, 9, 10, 11, 12. This is a 10-turn pot, and I just heard it
Check
click.
the pins on the pot.
Okay.
Otherwise, that pot is dead.
So let's go with here to here. 0. Okay, right here we got 12 volts. So right now we got 0 to 12. So that's a full swing pot. And in the middle we got nothing right now. But that's to be expected because I'm all the way one way right now. So let's tune this pot in. Which way was I going? Was I clockwise or counterclockwise? Let's go this way. 1, 2. Okay, that's click. So that's all the way one way.
Dead po clockwise.
1,
Clockwise.
okay, I adjusted it and the pot changed. So now it's at half a volt. So now,
That spot is dead.
put this way. Hold still, you. Let me get a clamp on this thing.
Oh,
Getting annoying. Put you right here. That should be the negative side. So let's put our clamp
I
here.
think we're onto something.
Sounds like it. Okay, so we got our clamp there. Let's run. Come on now. Had you in there all this time and you ain't giving me a bit of trouble. Alright, right back in here. Gotcha. Alright, so we should have our ground connected. Let's double check that. Okay, so the ground is connected. Our potentiometer pin is right here. That's our sweep. And as we adjust it, it should go up or down. Let's see. Okay, it's changing. So let's go the other way. Okay, can you see that? Okay, it can. Okay, so right here we're about to hit 1 volt with the potentiometer. Right, there's 1 volt. So halfway will be 6 volts.
Yes.
1.6. 2.
So is it a dead trace out on the board?
Now we're up to 3. Let me put this at 6 real quick and we'll recheck everything. 4. 5. And we're almost there. And right there is 6. So that should be halfway right there. So now we should have almost 24 volts out. And we still have 11.69. On this side we have 0, which is to be expected. And on this side we have the full 11. So the pot doesn't seem to be malfunctioning, at least not of yet. We can flip this back over. Rotate, rotate, rotate. Okay.
Bad trace on the board.
Gotta be somewhere. But we're getting voltage through it. That's what's annoying me. Okay, so we got positive going through there. We'll test out. Okay, you're off screen. Let's go over here. You can see what's going on a little bit better. Okay, let's test out our 6-pin chip. I'm going to call that pin 1. I can't see a dot on it, but I'm going to call that pin 1. 0.14. Pin 2 is 0.14. Pin 3 is 0. Pin 4 is 0.14. Pin 5, that's the full voltage, and it's negative. So that's a negative voltage. And then pin 6 is a negative 6 volts. And let me make sure. Okay, I have that hooked up backwards, so my meter's reading wrong because I have the negative connected to the positive. So in reality, this is going to be a regular 11 volts positive and a regular 6 volts. So let's trace this down. On this pin, we have the potentiometer running because I set that right at 6 volts. So there's our 6 volt lead to the chip.
Switch them around.
This will be the 11 volts from the power supply. Put this here.
You might have a problem just trying to drive power the wrong way through the ship.
Second floor, hardware, children's wear, ladies' lingerie.
Okay, let's try this here.
Chinese parts don't like that.
Going down.
Here. And here. Alright, so let's double check our connection. Okay, we still got the 11 volts. So looking back at our chip, pin 1. Whoop, there's something. That pin actually looks like it might be doing something. Let's throw a scope on that one.
Solder some jumpers real quick to the module pad so you can mount the board on Magman straight. Straight. I have that stand, his name is Magman.
Yeah, I'm keeping an eye on it.
Made from outdoor floodlight mount.
Okay, that just looks like a positive run. There's no change in the voltage there. Nothing on pin 2. Wait a minute, let me back that up on pin 2. Okay, positive 12 volts on pin 2. Let me change to my readout over here. Need to clear all my reads. Let's see here. Black, white, DC coupling. Display. Where is it? Measure. Clear. Alright, let's delete all items. There we go. Now we can go over here to VMAX and activate that. Okay, go back over to here. Yep, that's 12 volts. That's 12 volts. I'm calling it 12 volts. It's close enough. It's 11 and change. Nothing there. 12 volts. 12 volts. 6 volts is 5.9, but 6 volts we'll call it. 12 volts. Ground.
Chips working.
But the problem is we have no oscillation out of that. We should have some sort of an oscillation out of the chip. And it's just a flat wave. There's nothing.
You already see the voltage divider. Check the resistor.
Right here. Okay, we got 0 on this side.
Big one on the right.
Big one on the right. Over here. That's a diode right there. And on this side we got positive 12 volts, and on this side we got...
Request a song by typing SR then the name of the song.
Check that out real quick. There we go. What we got here? All right, let's get a frequency reading on this. $60 hertz. Yeah, that was just a loose ground. There wasn't nothing there. Okay, so we got 12 volts there also. So basically we got 12 volts everywhere. We have input signal everywhere except where the pot is. We got no oscillation, we got no reflection, we got nothing except 12 volts running straight through the unit. We got 12 volts here. We got 12 volts here. 12 volts here. 12 volts here. That's a straight short running straight through. On this side, nothing, which should be nothing. That's our grounding side of the cap. On this side, we got 12 volts. On this side, we got nothing. On this side, we got 12 volts. Resistor, this side, we got nothing. On this side, we have nothing also. Yep, nothing on that side of the resistor. Resistor's zeroed out on both sides. On the chip, we have 12 volts on pin 1. 12 volts on pin 2. Nothing on pin 3. 12 volts on pin 4. Nothing on pin 5.
Trace that from the resistor back.
12 volts on pin 6. Okay, so the trace on the resistor. I might have to get my microscope out to look at that. Let's see. Right
What
here.
comes before it?
Let me take that. Well, hold on a second. Let me look at the other unit. I already got it out of the clamp, so I don't have to move it around as much. On the other one, we have... Okay, so this side of the resistor is ground.
We need focus.
Thank you. Autofocus don't like the close-up work. Get over here. And focus. Alright. Clean the lighting up a little bit. Alright. So, that resistor
Can almost read the board now.
Well, you're about, I'm going to say 7 inches from the board. And I mean, you know, you can do this. And move you in over here and down a little bit. And there we go. Now, let's adjust it just a little bit more.
That camera works nice.
There we go. Thank you. It's standard webcam. I haven't made any changes to it yet, but I will be making them soon. Now, I'm trying to look. I'm actually looking at the same picture you guys are looking at. It kind of looks like that resistor is connected to pin 6, what I'm calling pin 6 on the chip. I can't tell for certain because the trace is running. Let me get a pick here. The trace is running underneath this capacitor. So this side resistor runs underneath the cap, and I can't tell if it goes to this pin or this pin. So, check the resistor again. Nothing on the resistor, and one of these pins, if it's connected here, should have nothing on it. Okay, this pin has 6 volts.
Number we can find a schematic.
And with this one is nothing. So I'm thinking, yeah, that one's hot. So that resistor is connecting right here to that pin on the chip, which is, I'm calling pin 5. So I'm calling that resistor is connecting to pin 5 on the chip. Right here in the middle. If you can see on my dental pick, it's right there. That pin and that resistor are connected together. Now the schematics. Let me see here.
Can see it.
HW045. All right, H045. HW045. Cancel that. Not downloading nothing. Still looking around on the web.
The chip number might be meaningless.
Well, I think I've pulled it up. Let me share the screen here. Just a minute, I could create a new scene. Let's see here. Let me flip this over here. Go to the second scene. And we'll go down here to games. Let's see, we got anything for Chrome? No. Okay, so I gotta create something. I'm not using Chrome, so I gotta adjust this real quick. And I wanted to grab... No, is that it? Oh, that isn't what I want. Well, I don't want to capture it. Okay, so we're going to have to do the inception thing. Well, hold on. You're going to see some inception, but it shouldn't take long. Let's go down here. Turn that off. And go to display capture.
Hey.
How's it going, Maketronics? Alright, why don't you want to capture? May not be able to show you. I don't know why that ain't. Nope, ain't going to want to do it, does it? Even a straight display capture isn't working. I upgraded Streamlabs, and since I upgraded, all my stuff's been messed up, so... That makes no sense why it ain't capturing a display. I mean, it's just a straight up display capture.
OBS always works.
Alright, take that out. Add a scene. Display capture. And nothing. Okay, well here I'll put a link. This is what I found. Let me switch it back over. This Control C is what I've located. There we go. You guys should be able to see that now. It's a PDF, and if you look down to what, one page? Yeah, the very first page. It shows the typical application of the chip, which I'm calling pin 1 is connected to the inductor, which it is. Pin 2 is connected to voltage in, which it is. At the same time, pin 2 goes through capacitor, and it's connected to ground. That would be the first capacitor right here. The next side would be ground only. That should be that pin over there, and I believe we registered that as ground. Let's look at that real quick. Okay, I got hot voltage there. So, is this ground? No. Is that ground? Okay, so I'm reading this side as ground here. And that doesn't make any sense because this right here should not be ground. And now it's hot. Okay, I still have nothing on this middle pin right here. And then on the
It's
upper
mirrored or
pin,
what?
I'm not sure, because this side, I have ground nowhere. Not here, not here. Well, now that's ground. See, that pin's intermittent, it looks like.
Try pin 5 with respect to the cap and the resistor.
So over here, pin 5 is still 0 volts. It goes right here to the resistor, which is 0 volts. Capacitor.
Conductance.
Okay. To see if the trace is good. Let's kill the power to it.
Just to see where the signal lands ourselves.
Alright.
What are you doing? Poking at one of those cheap MT3608 step-up boards.
Yes, I am. Okay, that right there is the connection. I don't know if you can hear it beeping or not. So it's a middle pin to resistor. And the ground, which, I mean, that's ground, that's ground. This isn't ground. Let's see if we got ground anywhere on this thing.
Okay, now should we be expecting power at that resistor?
Okay, so at that resistor, we should have voltage out. If this diagram's correct. But if the diagram's correct, then they literally have their traces ran wrong. And look, see if there's any other examples of the same
It looks
converter.
mirrored from that chip.
HW405, 24 volts.
The cerebrum has suffered massive and irreparable damage. You never know what has happened to him. Had I not been sure of this, I would not have permitted him to live.
I think I'm just gonna have to order a heavier,
Does
higher
it not match up
quality.
with? I have to admit I haven't looked terribly closely at these.
I think I'm gonna have to change this up. Oh, you got one right here with a different boost converter. Okay, so I'm looking at a diagram that Maketronics gave us.
Here.
Okay, let's look at what Gamer posted.
It says pin 5 is an input.
Individual to experience pain, pleasure, memory, dreams, or thought of any kind. This young man will be as unfeeling, as unthinking as the dead until the day he joins them. I don't know whether I'm alive and dreaming or dead and remembering.
So pin 1 would be ground on this one.
You can't even tell when you're awake and when you're asleep. Where am I?
I'm looking at Gamer's list, and it's showing that pin 1 would be ground. Pin 4 is the enable pin. Pin 3 is the feedback input.
Probably from the variable signal down to control the chip's output frequency.
Yes. Supply voltage on pin 6 and output voltage on pin 2.
555 timer.
Well, 555 timer, is that not... I have some 555 timers. Is that not an 8-pin chip? Correct me if I'm wrong, but...
I still think that variable resistor is dead.
Let's look here. Yeah, that's a 358 op amp, so that's my op amp bag. Looking for 555 timers. Yeah, 555 timers are 8-pin chips. There we go. 555 timer, 8-pin chips. I don't think they make a 555 timer that's not an 8-pin.
Ground is on pin 2 where I'd expect.
So let's go back to where we was at. Ground on pin 2. Okay, let's chase this down. Okay, so if we're going by this diagram, then we got ground on pin 2, which should be here. Nothing on that one. We could go to this one, we got ground. So if we're calling that pin 2, then this would be pin 1. And if that's pin 1, then that will go to ground. Okay, so that was make trip. So let's look at make's diagram. It's not showing, it's only showing 5 pins on make's diagram. This is a 6-pin chip, but let's just assume that 1 pin's carried over. So if that's the case, then we have ground will be on a corner pin. So that would be pin 3, no, pin 2, got it. And then pin 1 would be switch.
Down to the next page for the actual pinout.
Got it. So the switch would be on pin 1. So this should be a switch. It's running underneath the inductor. Okay, it runs underneath the inductor. Look at it over here. Okay, if it runs under the inductor, there's no place for it to go other than the inductor or positive. So, switch would be output. Let's see, power switch, output switch is the drain of the internal MOSFET. Okay. Connected to the power inductor and output rectifiers, the switch can swing between ground and 28 volts. Alright, following you there. Pin 3.
SW should go to the inductor and diode. Yeah.
Yes, and I think that's where it's going, so let's check that out. So if it goes to the diode, then it would go here. And that's correct. The switch is going to the diode. So that's going there. This one's ground. Pin 3 would be what? Okay, pin 3 is a feedback input and is connected to a resistor divider. So that would be this pin right here.
but nobody helped me. I've just got to do something and see how I can go on like this.
Okay, so if that's connected to
I'm so tired of being
here
suppressed by all my
to there. So that's correct because that's going to the wiper of the potentiometer right there on what I'm calling pin 3. Pin 4 is regulator on-off control input. High input turns on the converter, and low input turns it off. When not used, connect pin 4 to the input supply or okay, so pin 4 should be connected to input supply. Pin 4, so that's 1, 2, 3, 4 to the input supply. Got it. Pin 5 is input supply pin. Must be locally bypassed. And then pin 6 is not used. So it looks like it's wired up correctly. So if it's wired up correctly and the resistor's not bad. That's a 222 resistor. So that's correct. Diode. Let me go over here. Okay, the diode isn't blown. So it has to be just simple fact that the chip isn't working. The chip's wired up correctly. All the other components are working properly. The potentiometer is dividing the voltage. The diode is rectifying it. It's not fouled because it's not reversing. The inductor has 2 ohms on it. That should be correct because it's a 220, so that'd be 2.2 ohms ish. So it's got to be the microchip. It has to be. There's nothing else left to foul on it. Going back to test mode. Let me adjust y'all's screen so you can see now.
Wouldn't surprise me.
Let's see here. Camera control. Bring y'all out. Focus should still be good. Bring it up a little bit. Alright, so back to testing.
Between SW and GND out of interest. Go to see a list of commands or to see the song queue, and more.
Let me see what your question was. What's the resistance between switch and ground? Let's check it. So switch is 2. Was that what we was deciding on? Switch is 2. Nope. Switch is 1. 5.63. So 5 ohms, 5k ohm. Yeah, 5k ohm. 5,000 ohms. And if I'm not mistaken, that should be half of the potentiometer. So you're getting that off of here. No, not getting it off of there.
Nothing obviously wrong then.
Okay, we got 30 ohms on that side, 36 ohms on that side. Let's see, 30. Well, it's charging because there's a capacitor on there, so I'm going to say 35 ohms. And then across the two, slow down. It's charging, but I'm going to say we got a 100 ohm resistor. That'd be 100k, I guess, 100k ohm. Settle down. I'm gonna say that's probably a 100k ohm resistor. Then between pin 1 and ground, check ground on this side, pin 1 and ground over here, we're getting 42, so that still stands about the same. Any resistance between here and there? None. Any resistance between here and here? This is volt in to volt out. Okay, volt in to volt out, there's about 160k resistance. And part of that has to be coming from the diode. Or no? See. Yeah, part of that's coming from the diode. So we're getting a 7-ish drop on the diode, which sounds right to me. Again, this isn't going to be exactly on because we're testing everything in circuit. So we got capacitors charging, inductors trying to charge and coil up. But, I mean, 0.7 sounds about right for the diode. Let's switch back over here to voltage. Power to unit on. We're getting 11.4, 11.7 out. and 11.85 in. 11.85 at the diode, so the only thing we're getting really is the diode drop. We're getting 11 volts at pin 1, ground at pin 2, 5.38 volts at pin 3. Now pin 3 goes to the potentiometer, so I basically have 5.3 volts there too. There it is, 5.3 volts at the potentiometer. Then going back over here, we have 11 volts, which of course my leads are crossed, so that's actually positive 11 volts.
The output voltage to something below the input voltage?
I have. It doesn't change nothing. Okay, now right there I'm getting a spark. I can't tell if you guys can see that or not.
Yeah, the variable don't respond at all.
But let me see if I can zoom in on that. First of all, let's get you closer.
Steady current regardless.
And clear us up so you guys can see what's going on here. And then
Because it looks that way, and it won't do much if the output is set to below the input.
Alright, so I'm going to test ground to pin 1, 2, 3, 4, 5. To pin 5 on this small chip. Go turn my light down a little bit so maybe you guys can see what I'm about to do. Let me see if I get it any clearer. There we go. Alright, so I'm connected to ground. And if you watch, there's a small spark right.
Try and adjust the pot so ref is below 0.6 V and see if that does anything.
Not hot. I don't know if you guys can see that spark or not. Okay, try and adjust the pot so that the voltage reference is below 0.6 volts. And see if that does anything. Okay. I can do that. I can do that. Sorry about my fingers. Normally before I ever stream, I always take a brush to my fingers and fingernails to clean them up. I just didn't get around to doing it today. I was having so much trouble with OBS, I hadn't had a chance to. Alright, so let's check here. Okay, I've got to back you guys up a little bit now. You're a little bit too close to the show. There we go. You guys was a little bit too close for me to be able to work in. All right, here we go. All right, let's get this right here. Get on there. Back that up. Oh, ain't gonna do it. Do it on the other side though. Right here. All right, test our connection. We're good. All right, we're at 7 volts. Okay, we're going down. We're at 6.9. We're at 5. Two, 1. There's 0.6 right there. And that's pretty much as low as it goes. Oh, sorry, y'all couldn't see the meter. There we go. Alright, so there's 0.6. Output voltage is... There it is, 27 volts. Did I read that right? 27. Alright, let's get that back up here.
So that's working then.
So is that successful? Let's test this out again. Here. And here. Okay, there's 27 volts. That's the first time we've gotten a positive, well, any voltage out of this side other than the input voltage. Alright, so we have, these leads are getting twisted. Alright, so we have 27 volts. Our goal is 12 volts.
Finally.
Okay, that's 27.8.
Areem, what's the input voltage? That's just lovely to see working now.
Okay, so that's 12 volts. Input voltage is more or less 12 volts. It's 11. 11.8. Yeah, 11.8.
Nice.
So we're boosting it up to 12 volts. Now, let's see if we can do the exact same thing with this one. Because this is actually the one we're going for. So, go negative here, positive here. Flip this sideways. Looks like we need to bring it down to a half a volt more or less and then bring it up. Okay, well that wasn't good. I think we burned up our charging circuit, so we'll have to redo that. Okay, so where was we? It was over here. It should have been off, and I had the switch on by accident. Apparently I bumped it on. So we'll have to redo our charging circuit. Hopefully that's the only thing that blew. Hopefully nothing in the battery blew. I saw the magic smoke and I said, uh-oh. That's when I looked down and realized the charging circuit was still powered on.
Funny, I don't smell smoke.
Well, as soon as we get onto that, smell-o-vision, we'll be doing better. Twitch isn't quite up there yet. It's working on it though.
Why are you converting 12V to 12V anyway?
I'm not. I'm actually trying to convert basically 4 volts to 12 volts. There we go. But right now we was under, you know, we're just trying to get it to work, period.
Also, I hope O_bother never has smell-o-vision.
Me too. Alright, so I think we burned up our charging chip. I always buy 2 things for that particular reason. Let's flip this around. So I have a secondary charging chip in case we did burn it up, which I'm pretty sure we did. I'm just hoping we didn't burn up the battery. I did order a second battery in case we do. Hopefully we didn't. Turn this off for a second while I get my clamps sorted out here. If O_bother gets smell-o-vision, we'll really be in trouble. We'll be smelling the homebrew all the time. All right.
I love watching this. Looks as hazardously worked as my own desk.
Yeah. I need to take time and just clear everything down, but I ain't got around to it yet.
Looks cleaner than my desk.
Oh, it does? Okay. Alright. So that's connected there. That's connected there. Well, I need a new top. This is a paper top and I need to replace it. So that'll clean things up a bunch once I do that. Alright, so we got 11 volts coming in. Nothing there. And let's adjust this down to, what do we say, 0.6? Alright, we're going the right way. There's 10, 9. And my finger's really big. Okay, let's go over here. That was a big knuckle on the screen. Okay, 7, 6. Oop. That's 5 volts. Four, 3, 2, 1. 0.7. I'm going to test the output. Output is still 11 volts. 12, 13. Let's call it 13.8. Alright, let's turn this off here. And I just dropped my whole battery pack. Well, the solder didn't come loose yet, so that's good. Alright, let's scoot this back. Now, if I didn't burn everything up, I should be able to flip this switch. Switch is on. And I should have... Okay, there's my 3.6 volts from the battery. There's my 13 volts out. So, it should be working right now. 13 volts out, 3.6 volts from the battery. Turn it off so I don't burn nothing up. Now let's give this whole thing a shot, what we've been trying to do this whole time. Scoot this out of the way. Where is it? Unclip this. Got to resolder all this too. I've been dropping it around so much it's already messed it all up. Okay, so where are we at? Here it is. Okay, so I'm connecting white to positive, yellow to negative. Over here, you guys can see that. Yellow will be the ground and the negative on the motor. And white should be the positive. Alright, let's see what happens, if anything. Get all this over here. Alright, let's see here. Reach over for the switch. Let's see what happens. Whoop. Already trying to take off. Okay, here we go. There it is. Switch on, off. Okay, so now let's do this. While it's on, let's see what the voltage is at when it's on. So see how much of a voltage drop we're getting. Here.
All right.
And here. Alright, so let's back up to the voltmeter a little bit. We'll flip it on and see how much voltage we have at the motor with the unit running. 8 volts. Okay, let's see what I got here. 8 volts.
Hello.
Hello. Alright, where did it go? Let me turn that off. Who we got there? Hey there, how's it going, Russell? I know your name's not Russell, but easier for me to say. Alright, so where are we? We're getting no voltage now.
Doing good. Getting hungry again, lol, but good.
Well, good. Okay, we're right back where we was. So everything should be right fine. Let's turn this off. Let's check our voltage out here. Okay, so our protection circuit is shutting the battery down. Probably because of the charger. But we do have it up and running. So now all we need to do is to redo the charger. See if I can see what blew on that, unless it's just the chip. 1, 2, 3 resistors, an LED.
There's something wrong with the world today. I don't know what it is.
Now I may have inadvertently messed up the circuit on the battery
You sure
too.
that is going to power that motor?
Yeah, it ran it just fine. Now it isn't charged up, it's just barely charged up, so we ran the battery down pretty quick. But yeah, it powered the motor fine. I don't know how long. Let's see. This is a 5200 microamp hour battery. So 5 amp hour battery. A 5 amp
Looks
hour
like my
battery.
thumbnail.
Looks like what? Your thumbnail? Oh, okay. A 5 amp hour battery. So let's see, 5 amp hours at 3 volts. 3 times 5 is 15, so that's going to be 15 watts. So it'll provide 15 watts for 1 hour. 12 volts at a half an amp. So 12 times 0.5 is 6 watts. So it should run it for half an hour. You guys can correct me if my math is wrong. The motor draws 12 volts at half an amp, and the battery is a 5400 milliamp hour battery. The converter's a 96% efficiency, so we can pretty much call it 90% efficiency. So yeah, it should power it just fine. Let me see what's going on in this chip over here. Unhook that one. Well, let's disconnect this.
Hi baby, it's literally 0.6.20 baby bear.
Okay, I'm fixing to wrap it up. Yeah, with no load on it right now, the battery's at 1.28 volts, which is what the cutoff voltage is for the circuit. So I think the circuit is cutting the battery off. My only hope is that I didn't accidentally fry it when I put 12 volts to it. So I may have blown the battery up too, but we'll just have to see about that later. Alright, so let's look at this. Love you too, babe. See if we're getting any output from the charger. Where do you go, charger? I love it when your components are smaller than the plug it's plugged into. Alright. Go on there. Here. They go here. Okay, we got nothing coming out of our charging unit. So I'm pretty sure I blew the charging unit. Can't quite get to the pins. Let's say that pin there. Okay, I might not have. Let's see. In a bag, where's that at? Here it is. Let's just test this out real quick. Fixing to call the stream, guys, so thank you all for joining and watching, and if you haven't already, hit that follow button. I think everybody here is pretty much a follower though, so I appreciate that. Okay, here's a brand new one. We're going to connect it up to our power source.
It's time to have a drink. We need to stay hydrated.
Okay, so that lit up. So I'm thinking that it's just that charging unit's blown. Flip this over. Work on my Chinese chopsticks maneuver. There we go. 4.16. So this one's working fine. The other one's blown. We blew it when I inadvertently gave it 12 volts backwards. Well, I actually gave it 12 volts forwards, but it tried to shut everything down to regulate, and of course it can't regulate what it isn't got going into it, so I'm afraid I bricked that little fella. Feel sorry for him too, because he was working fine. All I was going to do was clean him up real good and give him a case, but looks like his brother's going to have to take over. Next time though, I'm definitely going for a larger charging board. When I ordered these, I was going for the smallest charging board I can find, and I literally found the smallest charging board I could find. But it's almost too small to work on, because you got to run these jumpers across here for what amperage you're running and what battery you're running, and them buggers are finer than a human hair, so I mean it's
Crazy Old Gamer.
Definitely something you got to do. Thank you so much for the follow, Crazy Old Gamer.
That is an adorable little charging board though.
Oh, it is. It's called Tiny, and it's put out by a company that puts these out. It's called Tiny Circuits, and they put out a whole bunch. Here, let me zoom in on here so you can appreciate it. They put out a whole bunch of circuits that are really small, and I really appreciate them for it. I read the size, and I guess it was one of them things like your stomach's bigger than, you know, your eyes are bigger than your stomach or whatever, and I read the size, and I thought, oh, that's just going to be fine, and yeah, it's pretty much too small to work on. Alright, let's clear that up. There we go. Now, this is a dental pick I got coming in, so if it looks like a monster, just don't worry about it. This little wire right here, if you see that little line right there, I had to remove a resistor from this side, and that allowed it to go up to a 1/2 amp charging. And then I had to connect a jumper, which is a little wire I got right there, from here to there. And that allowed it to go to 4 volts for the charging setting. So love the charger, because you can set it to 3 different types of batteries, and has 2 different charging modes. You can put it on a 100 milliamp or a 500 milliamp. But setting that is a dickens. So I really appreciate it. It's made by Tiny Circuits. Let me flip this over so you can get a good read on it. And there we go. Remove the light. There it is. Tiny Circuits. Nice company. I can't complain about them. I've bought several things from them, and everything comes in and seems to work. But boy, is that a bugger to have to solder on. You just about need a microscope and a micro soldering iron to do it. I did it with this point right here. So it's pretty much a little bit too big to to work on them tiny side on the other side of this board. But alrighty, so as a conclusion, we know that our battery will power the board. We got our two boards set for 12 volts thanks to chat. I did not think of bringing it all the way down to 0.6 volts and then bringing it up. I did go both ways with it, so I took it all the way down and tried it coming up, and I took it all the way up and tried it coming down, so I don't know why it didn't do that in the first place, but thanks to chat, so now I got two boards, this one and the other one. Well, that board looks like a monster next to the little board. Look at that. He just dwarfs the little charging circuit board. And so now both of my boost converters are working that I know of. So now I got that lined out. And that was all thanks to chat. So thank you, chat. Let's see what else. We're going to try to finish this project up on the next stream. I'm also going to be streaming a lot of video editing because I'm putting out a system on my YouTube on how to reinstall Windows without all the bloatware and everything. So I've got the first video up, and I'll be putting the second video up shortly, and I stream my editing and making of the videos. So next stream might be video editing, I'm not sure, but we'll just see how things go. But thanks everybody for joining. Let me see who all we have. I think we have 2 follows today. Yes, we have 2 follows today. Chip Achero followed, and Crazy Old Gamer is followed. So thank you all for the follows. I'll be appreciate that a lot. I really appreciate follows just as much as I do subs, so don't worry nothing about subbing. And you do get benefits for following. So you got song requests and stuff that you can run. Also, I'm not sure if the games are running. Let me see if the games are running.
Highest.
Nope, games aren't running. Don't know why. I've got to work on that. My chat bot's been giving, all of them's been giving me trouble. I updated everything, and since then I have to redo all the commands and all that. Let's see here. Mini games. Maybe I need a capital H. Try capital H. H-E-I-S-T. H-E-I-S-T. That's what I got wrong. H-E-I-S-T.
Heist.
Nope, still isn't running. Gonna have to fix that. I'll be running some tests on it, looks like.
Catch ya later.
Alright, have a good one, guys.
Heist 100.
There we go.
Dash is trying to get a team together in order to hit the nearest bank.
Now we got it going.
Everyone can join. In order to join, type heist amount.
So now I got the heist working. Had a few settings I had to adjust. Oh, guess nobody's going to join in on the heist, are they? Let me see here. Doesn't look like anybody I normally watch is streaming, so I'm just going to shut it down, guys. So thank you all very much. No raids for the day. We'll see you all later.